All right, so let's do some actual balancing here. These are some hints or tips that we're going to talk about and then practice and kind of add it to your arsenal of strategies that you're going to use when you're balancing equations. And trust me, you will get better at this. You just have to take time and get used to this stuff. All right, first tip is start with atoms that appear only once per side, meaning they're not in multiple formulas on the same side. So if you're not sure where to start with and you see something that shows up a lot, don't start with that one. Start with things that are kind of rare and you only see them in one compound per side. Another tip, when you have 2 of something on one side and 3 of the same thing on the other, try to get 6 on both sides. And we'll practice that strategy in a second. Worry about O's and H's last. You want to balance polyatomic ions as a unit, as a group. Don't break them apart if you don't need to. And anytime you have odds, evens, issues, which I'm going to show you how this all works out in a second, you can resolve that, you can fix that by doubling everything. If you find out who's making it odd, start doubling everything. And then suddenly your odd number becomes even because you multiplied it by 2. You've doubled it. And that'll fix a lot of issues for you. So let's go through some of these hints step by step, and let's look at how we can employ this strategy. So the first hint that I want to really work out is the 2-3 business. So when you look and you see 2 of an element on one side and 3 on the other, try to make them 6. So if I look at this equation here, I see oxygens. There's 2 oxygens on this side, and on this side there's 3. The goal is to make them 6. So I need to know what number to put here to make this 6, and what number to put here to make this 6. So 3 times 2 is 6. Over here, 3 times 2 is 6. Now, we're almost done here, but the 2 in the front of this, I'm going to build 2 of these. They each need 2 aluminums. So 2 times 2 is 4. I better start with 4 aluminums so that I can build this. And then we're balanced. Over here we see a 3 and a 2. Make this 6 and make this 6. And now your chlorines are balanced. And then just look at what happened when you put that 2 there. 1 isn't good enough. We decided to make this a 2, so that means we also have 2 of these P's. So we put a 2 here. We can't leave extra P's around. We're going to make 2 of these. This next one, I got a 3 and a 2, so let's make them 6. Put a 2 here and a 3 there. And look at this, a 2 and a 3. After the hydroxide, there's 2 hydroxides here, there's 3 hydroxides here. Let's follow the same rule. 3 times 2 is 6 hydroxides. 2 times 3 is 6 hydroxides. And look at what that did for the other elements that aren't the 2's and the 3's. Over here we have 2 Fe's. Over here we have 2 Fe's. 3 Ca's. 3 Ca's. So everything's balanced, and we did it quickly by looking at that 2 and 3 and trying to make them 6. This last one here, I got a 3 and a 2, put a 3 there, put a 2 there. That also impacts your K's and your Cl's. So we're going to have 2 of each, put a little 2 there. You're all done. 2's and 3's make them 6. The next hint. Worry about oxygens last. The reason is oxygens and sometimes hydrogens, but oxygens often show up in more than one compound. So we want to tackle them last. Get every other element straightened out first, and then worry about oxygens. So in this first example, we got 1 calcium, 1 calcium, 1 carbon, 1 carbon. So those guys are good so far. We got 3 oxygens. Look at what we have over here. Here's 1, and then here's 2. 1 plus 2 is 3. So the 3 that we started with will get split up. One of them is going to go here on the calcium oxide. The other 2 goes with the carbon dioxide, but there's still 3 on the product side. So this equation is balanced just the way it's written. Now this next one. We're going to tackle oxygens last. Why? Because there's oxygens here, and then on the product side we got them here and here. So let's deal with them last. Let's start off with the H's. We got H, one of them, no other H's. On the product side we got 2 H's. So go back and make this 2. We go back to the stock room. 1's not good enough because we need 2 in the water. So we're going to start with 2 of these guys. Now that 2 took care of our H's, but it also impacted our N's. So here, watch this. We've got 2 N's and we've got an N here. So that's 3 total N's on this side. So on this side, I want to have 3 total N's. So I'm going to put a 3 here, which is going to impact our oxygen. So now that we've got our H's straight and our N's straight, now we can worry about oxygens. 2 times 3 is 6. 1 times 1 is 1. 6 plus the 1 is 7 oxygens on the reactant side. I got to end with 7 oxygens. Well, there's an imaginary 1 here times 1. There's 1 oxygen. And then 3 times 2 is 6. 1 plus 6 is 7. So this is balanced. 2, 1, 1, 3. Do oxygens last. Get everybody else straightened out. So let's look at the example down here. Combustion of methane. 1C, 1C. 4 H's. Over here I only have 2 H's. So that means I'm going to have extras. If I have extras, build more. So instead of just building 1 water, I'm going to build 2 waters. Now that took care of my 4 H's. So my C's are good, my H's are good. Now I can focus on oxygens. So oxygens, I've got 1 times 2 here. On this side, I've got 1 times 2 oxygens, plus 2 times 1, 2. So 2 oxygens plus 2 oxygens equals 4 oxygens on the product side. I want to get the reactant side to equal 4, so what number goes here? 2, because 2 times 2 is 4. So when this equation's all balanced, it's going to be a 1, a 2, a 1, and a 2. Let's look at this last one here. When I see this big mess, I know oxygen's here and here on the reactant side. On the product side, it's here and here. So that to me is a huge warning sign to tackle it last. Don't try to deal with O's when they're all over the place. Get everything else straightened out. So the carbon, I got 6 carbons here. I need 6 carbons here. So I'm going to build 6 of these carbon dioxides because they each need 1 carbon. Now hydrogens, I've got 12 here. I want to have 12 here. So what times 2 gives me 12? 6. 6 times 2 is 12. Now that I've got my C's and H's straight, now I'm going to worry about my oxygens. So over here I have 6. Right now, with an imaginary 1 here, I have 2. Let's look at what I got on this side. 6 times 2 gives me 12. 6 times 1 gives me 6. 12 plus 6 is 18. I've got 18 on this side. Now I need this side to equal 18. I do not want to change this, because if I put a 2 here, or a 3 here, or a 4 here, or if I change that in any way, shape, or form, I then mess up my C's and H's. So I'm going to try to keep this a 1. That Out of my 18, that takes care of 6 of them. So I need to get a grand total 18. I've already got 6. So now I just really need 12 left. So what goes here that when multiplied by 2 gives me 12? A 6. This is the formula for cellular respiration. We break down glucose with the oxygen that we breathe. We produce carbon dioxide and water vapor, and it's not in this equation, but that energy molecule, the ATP. So this is what we do. And if you look at it in reverse, this is actually photosynthesis. This is what plants do. They take in carbon dioxide and water vapor. They use some energy from the sun, and they make glucose. This is glucose and oxygen that they release. So this is a little bit of a crazy looking formula, but if we focus on oxygens last, it's really not that difficult. All right, balance polyatomic ions as a unit. So if you recognize your polyatomic ions, you're going to have it easier than a kid who does not recognize them. So if I look at this equation and I don't recognize polyatomics, I might worry about the N's separately and then the O's separately, and then I get over here and I have to do one of these distributions, and if I put a number here I might have to distribute on top of that, and things get really confusing. So if I recognize, oh, that's nitrate, then I can look for nitrate here. I see, oh, that's nitrate also. There's 2 nitrates because the 2 goes to the whole thing in parentheses, which is nitrate. So if I see this as a 2 referring to the nitrate, I know this side I need 2 nitrates, so I better start with 2 nitrates. So I put a big 2 out front. That 2 is going to go to the whole nitrate formula. So it's easier than separating the N's and the O's. So not only did the 2 go to the nitrate, but it also went to the silver. Remember, there's imaginary 1 there. So 2 times 1 is 2. So I better have 2 silvers on this side. And then I look at my copper. 1 copper here, 1 copper there. I'm good. That imaginary 1 tells me this is just 1 and 1. Look at this big mess down here. What polyatomics do we see? OH is hydroxide and PO4 is phosphate. And NH4 is ammonium. Remember, that's the only positive charged ion. So I got a lot of atoms here, but I really have 3 groups. And then little old aluminum. So I got 1 aluminum here and 1 aluminum there. But all the rest are polyatomics. So let's start off here with hydroxide. There's 3 hydroxides. Over here, there's only 1. I want 3 of those hydroxides. I'm going to put a big 3 in front. That 3 goes to the hydroxide. It also goes to this, which is a polyatomic ion, a group. So I got 3 of those groups. Let's see what I got over here. There's my polyatomic with a 3 after it. Good. That's all set. Now this phosphate, PO4, there's 1 of them because I don't see it in parentheses with a number after it. So there's 1 phosphate. And over here, same group, 1 phosphate. So this is now balanced with a 1, a 1, a 1, and a 3. That would have taken a lot more time if I had to look at every single one of these elements individually, especially when the H's are here and here, and here and here. So seeing that it's part of a polyatomic makes things easier. Now there's an extra little trick with hydroxides. Ideally, you see hydroxide on both sides of the equation, like we did here. Here's a hydroxide, here's a hydroxide. Perfect. But if you see hydroxide and then you look for it on the other side, you don't see it, it might be because it's hidden in water. Look at water. Here's the 2 H's and the O. We could think about water as a hydrogen and a hydroxide together. So here's the extra little tip. If hydroxide's on one side, doesn't matter which side, but if hydroxide's on one side and it's not on the other, but water is, then you can rewrite water to make it seem like it's a hydroxide. Just take that H2O and split it into an H and an OH. So this is how I would go about looking at this equation. I would see sulfate. There's one of those sulfates. There's three of those sulfates. So I'd go back here and put a 3 there. Then I look at my hydroxides. I see that there's 3 hydroxides. Over here, I see water. I don't see a hydroxide. So I'm going to take my water and I'm going to get rid of that formula. And I'm going to write H. And I'm purposely going to leave a little space here. And I'm going to write OH. Just so that hydroxide jumps out at me. And this H is kind of a single H now. But this is still part of the formula. So whatever coefficient I put here goes to both of them. So now, go back to the hydroxides. I got 3 hydroxides. Over here, I only have 1, so I put a 3. The 3 goes to the H, and the 3 goes to the hydroxide. So now my hydroxides are set. The next thing I'm going to do is look at my aluminum, 2. I got to put a 2 here. Uh-oh. That took care of my aluminum, but what did it do to my hydroxide? I have 3 in each one of these, and I have 2 of them. So I have AlOH3, AlOH3. I have 6 hydroxides. So what do I need to do? Make sure over here I have 6 hydroxides. So this 3 is not good. I'm going to put a 6 here. So now the 6 goes to the hydroxide. 6 times 1 is 6. That's great. But it also goes to my H, which is awesome. 6 times 1 is the same as 3 times 2. That's 6. So everything is balanced here. All my H's work out. My sulfates work out. My aluminums work out. And my hydroxides work out. Even though I didn't see hydroxides initially, I've got that OH. It's a little easier if you rewrite the water so you can see that hydroxide, and then you can balance it as a group. So 3, 2, imaginary 1, 6. Let's look at the next one. I see phosphate. Over here I see 2 phosphates, so let's fix that. Now, I also see hydroxide. So I look for hydroxide on this side. I don't see it, but I do see water. The only time you use this trick is if you see hydroxide on one side and water on the other. Don't use it every time you see water. Only if it's hydroxide and water. So I'm going to rewrite it as H and then OH. So now I got 2 hydroxides here, only 1 here, so I'm going to fix it. I'm going to put a 2 there. What did that do? That impacted my hydrogens. So I've got 2 H's over here. Oh, I had 6 H's. So that means we got to go back and fix that 2. That doesn't work anymore. I've got 6. Now the 6 can take care of my H's, but it also impacts my hydroxides. So I've got to have 6 hydroxides here. So I've got a 2. What do I put in front? 3. That takes care of my hydroxides. And the last thing, I got 3 coppers over here, 3 coppers. So again, treat that hydroxide as a group. It's going to be much easier than trying to deal with separate H's and OH's. And the last tip. Anytime you have odds on one side and evens on the other, double everything. Figure out which one's making it odd, and then go back and double everything. So if I'm working this one out, I got a sulfur and a sulfur. I've got 2 oxygens, 2 oxygens. That's 4. That's an even number. Over here I have a 3. That's odd. So I'm going to figure out which one's making it odd, and I'm going to start there. This is an imaginary 1. That is odd. 1 times 3 is 3. So I want to double that 1. I'm going to make it a 2. So then I have 2 S's. So I go back here and I double that. What does that do to my oxygens? Because that's going to impact it. 2 times 2 is 4 rather. Plus these 2 is a grand total 6 oxygens on this side. What do I have on this side? 2 times 3 is 6. So it's a 2, 1, 2. Let's look at the next one. Do oxygens last. I got 2 carbons. Let's fix that. I got 6 hydrogens. Let's make this 6. 3 times 2 is 6. Now let's focus on oxygens. I've got 2 oxygens here. Whatever number I put here is always going to multiply by 2, so this side's always going to be even. But look what we got going on here. 2 times 2 is 4. That's even, that's good. But 3 times 1 is 3. That equals 7, and that's odd. So whenever you have evens and odds, start doubling. That 3 is going to become a, and I'm going to rewrite everything in red here, 3 becomes a 6. The 2 becomes a 4. The imaginary 1 over here becomes a 2. Which makes sense, because if this becomes a 6 now, 6 times 2 hydrogens is the same as 6 times 2, or 2 times 6, whatever way you want to look at it, but it's 12 hydrogens. The carbons, 4 times imaginary 1 is 4. Over here, 2 times 2 is 4. So the carbons and the hydrogens work out by taking that imaginary 1 and doubling it by making it a 2. So now I've got new numbers for oxygens. Before I had 7, guess what number I'm going to get now? Let's see how this works out. 4 times 2 is 8. 6 times 1 is 6. What do we get when we do 8 plus 6? 14, which we knew because we were going to double it. So what number goes here to multiply by 7, or multiply by 2 and give us 14? 7. So this is a crazy one. Hang on, the next one's even crazier. But we got a 2, a 7, a 4, and a 6. Let's look at the last one. Do oxygens last. Carbon, actually let me start with green again here. Carbon, we've got 8, so I'm going to put an 8 here. Hydrogen, we got 18. What times 2 gives me 18? 9. Now let's focus on oxygens. 8 times 2 is 16. 9 times 1 is 9. 16 plus 9 is 25. That's odd. And no matter what I put over here, it's going to multiply by 2 and turn out even. So I have an odds and evens issue. So what do? Start doubling. I'm going to start here with the one that's making it odd. 9 gets doubled to 18. Now, 18 times 2 for hydrogen is 36. Look what we got over here. 18, this was a 1. Now let's make it a 2. Let's double it. 18 times 2 is 36. It looks a little crazy because we got some high numbers, but that's okay. Now, whatever I do to this, I also have to do here. I got to double. 8 is going to get doubled. Now I'm going to have 16. 16 carbons. Well, that's what I get over here. 2 times 8 is 16. So far things are good. Now let's focus on oxygens one last time. 16 times 2 is 32 oxygens here. 18 times 1 is 18. What do you get when you add 32 and 18? 50, which we knew we were going to get because we were going to double everything. We had 25 before, now we got 50. What number do you put here to multiply by 2 and get 50? 25. So 25 goes here. So our coefficients are 2, 25, 16, and 18, and that is a set of one of the examples with the biggest or the highest coefficients that we're going to focus on. So take all these tips, think about them, and try to apply them as you do the whole set of practice examples right underneath this. We can talk about them in another video.